How's it going, YouTube? Today I'm going to show you how to build a Tic Tac Toe app in React in an interview context. So if you were presented this as an interview problem, I would show you how I would approach this. So this is a model after the React Docs tutorial, but we've cleaned it up and updated it with ES6 as well as React hooks. So let's jump right in. So first of all, we need to build a mental model of the problem. Then we need to pseudocode. Then we need to actually code. So over here I have a sketchpad. Now, basically here we have our squares. We have 9 squares, and technically these are 0 indexed, but right now I've written them out 1 through 9 just to make it easier. And if we think of it as a React context, we have a component which is a square, another component which is a board, and then each of these numbers represents an item in an array. So eventually this will be X or O, but right now they're empty squares. So if we think about that, let's go over here and pseudocode a bit. So we need a square component, and we also need a board component. And we're going to break this down one by one. So first of all, the square is pretty simple. It needs a value, and it also needs a function when it's clicked. So we're going to add a value here, and we're going to add an onClick function. And we know that these are probably going to need to be props. So that's pretty easy for our square function. Next, we have our square component. Next, we have our board component, and this is where things get a little more complicated. So the board component needs some kind of state management because we need to keep the state of the board as well as the state of whose turn it is. So we'll keep the board state and the turn state. So once that's done, then we also need a handle click function that will be passed into each of these squares. So we will call this handle click. And this is where things get a little complicated. So here, we have to basically edit the board state whenever something is clicked. So we need to add an X or an O. So here we will take a copy of our board state, and then we will mutate that copy and add X or O, and then we will set the state of the board. So another thing is we also have to calculate whose turn it is. So up here, we will calculate next turn, and then we will set the state of the turn. Now, another caveat is if you click an empty square and it places an X, and then it's player O's turn, and then they click the same square with the X, you don't want that to be overridden. So what we can say here is we can just say if the index of the array of the board is filled, we'll just return. Okay, and then the last portion is we need a function that calculates the winner. So function that calculates the winner. And that will take a bit of logic, and if you're in an interview, you just want to build as much as you can without getting tripped up. And if you have a piece that the rest of the game doesn't really rely on until the very end, I would recommend just going through and building out all the functionality until the last piece, because you can still play the whole game all the way until the end without calculating a winner, right? And if this is going to take up a majority of time and you might get tripped up, you'd rather just build as much as you can in this interview. So we're going to hop right in. And basically here, so we're going to build our square component. So this one is going to be pretty simple. So let's take some props, and all we need to return is some kind of div or button. I'm just going to use a button here. So basically each one of these squares is going to be a button, and this button needs a value, which is just going to be the value passed in from props. And then we're going to have an onClick function, and this is just going to be props.onClick. So pretty simple there. And I also have some default styling that's pulled into this. I'm using Create React App right now. Tic Tac Toe is being passed into the app component in another file, and that's rendering to the screen up here. So I'm also pulling in a CSS file. So down here, I'm just going to call this class square. Boom, and let's quickly render square to the screen. Boom, so we have square. Perfect. Okay, so now we need to build the board. So we'll say function board. So board does not need any props. Board is going to be the parent container. So board does not need any props. It's going to be the parent container. And then we can move all of our logic up here. Okay, so we need some kind of state, and we're going to use the use state in React hook. So I've pulled it in right here, use state, which is a React hook, and we're going to use that instead of set state and making a class. This is much cleaner. So we're using just a functional component. So we can use destructuring from use state to pull out our values. So basically, if we have the board state, we're just going to call this board squares. So this is going to represent our value, and then we have a function, and we're naming all this ourselves. We're choosing the names, and this is called set board squares. And all set board squares takes in is a new kind of board squares, and then what we can do is say equals use state, and then we pass in our initial value here. And then eventually this will keep being updated. And the nice thing is throughout our whole function, we can now reference board squares as a really quick value instead of this dot state dot board squares. So since we know we need 9 values, what we're going to do here is we're just going to make an empty array, but that's filled with 9 null values. So it's actually not empty. So here we're going to make an array filled with 9 null values. So we can use this shorthand, and this will just make an array that has 9 null values. So that was pretty easy to make our board squares. Now we need our turn state. So we can just say is X or is Y is O, but we're just going to say X is next. And then we need to also have a setter for that. So set X is next. And this is just going to be a Boolean, super simple. And we'll initiate it as a true. So the first person's turn, it will be X's turn first. Okay, so now we need our handle click function. And we know in the future that we'll need to be mutating this board squares array. So how do we usually do that? We need an index reference. So we're going to be passing in the index of the item that's clicked. And you'll see later how we access that. So now we've wrapped everything in here. So the first thing we need to do is just make a copy of our board state. There are a handful of ways to do it. So I'll just say const and then new board, or I'll just say squares. So const squares equals board squares. So we just basically spread all of the items in board squares into a new array. So now if the index of the board is filled, we need to return. So what are we seeing here? So we have this array that's potentially filled with values. And here, how do you check if something's filled or not? You just have to check if it's truthy or falsy. So what we can do is we can say if squares, which is our array of X's and O's, and then we have our index here. So all we're doing is just accessing an X or O, and it's the one that's clicked. So we'll just say squares index, then return. So if this is actually present, it's not null, which we've initially set up here. If this already has a value in it, we're just going to return. Okay, so now we've already mutated our copy, so we just need to add X or O. So pretty much here, we say squares index, so we're accessing that index in our board squares array, which is squares is just a copy of the board squares array, and we're going to set it equal to x or o. So what we can do here is say if x is next, so if x is next, we're going to use a ternary operation to set x. Else, if x is not next, so if this is false, we're just going to set o. So we've now mutated our copy, and now we need to calculate our next turn. So we can actually do that all in one line because we need to set the state of the turn. So what we can do is, let's set the state of the board first. So set board squares is just going to be equal to squares. So the copy of the board squares array that we mutated on line 39. And now we need to set the state of the turn. So we'll just use set x is next, and we're just going to take the opposite using the bang operator for x is next. So if it's x, this will turn to y. If y, this will, or if x, this will turn to o. If o, this will turn to x. And that's just coming from true being x and false, or yeah, false being o. So we've pretty much done our handle click function. So that's taken care of. And now the last thing is we need to create our board. So this will be pretty straightforward. We just need to return our 9 squares. So I'm going to use a quick VS Code shortcut using Emmet. So we can say div greater than div times 4 and tab that out. Boom, so there's that. And pretty much we need to place a status up here, and then we need to place our squares down here. So I'm going to make a function that will return a built square with the index in place. So what we can do here is create a render square function, and this is going to basically take a value from here and maps it to the actual square. So everything will be linked. So this needs to take in an index, and then what this needs to do is return a square with the correct value and function. So we can say render square. This takes in an index, and then what this does is it just returns our square. So return square. Now, what does square need? It needs a value, and it also needs this onClick function. And what is our onClick function? It is this handleClick function, but our handleClick function needs an index. So what we need to do here is when passing in an argument to one of these callbacks, we need to use an arrow function, and then we pass the index into the handleClick. So if we, this right here, this is the event object that takes place whenever you make an event on the DOM. So we don't really need that, so we can just leave that empty, and then we can pass the index into handleClick as this callback is called. So now if we think about what is the value, so the value passed into square is either a string, it's x, y, or it's null. And where do we get that from? We get that from board squares, which is our default filled with 9 null values. So what we can do, we already have access to our index, so we can use the same strategy here. We can just say board squares, and then we can pass in our index value. Boom. So this will grab either the x, y, or null value and map it to the square. So we have our render square function already here. Now what we need to do in these divs is we just need to place our rows. So we have 1, 2, 3. So each of these will be a row, and you'll see what I'll use this for later. So each of these are going to be a row. So what we can do is we can just pass in some JavaScript, and we can pass in index 0. So this will basically map index 0 with this square right here. And we just need to do this a few more times with 1 and 2 And we're pretty much done there. So we'll just copy and paste. And we have 3, 4, 5, 6, 7, 8. So let's take a step back and figure out what this is doing. So this is going to create a square with a fixed value that we passed in of 0. So we go up to render square, passes in 0, grabs the value from board squares. Right now it's an empty array of 9 nulls. It's going to grab the first one, pass in null there. So basically the value rendered to the square is going to be null. So this button is going to contain nothing. And then for our on click, we're passing in this handle click right up here, which will be called whenever we click on the square. And this index will be passed in to this handle click function on line 33. And the operations will then be made. So now we're pretty much done with that. We'll save, and we will render this to test to make sure it's working. Okay, excellent. So then I also have some default styles that I've added. So what we can do here is we can grab each of these divs and we can just call it board row and refresh. Boom, now we're in a row. And then we also need some kind of status to say whose turn is it next. So I'll just call this status. And we need to initialize status. So now up here, initialize status. So next we're going to initialize our status. So we'll say let status. And what we can do here is we can set status equal to next player. And now we can add some JavaScript to see who is the next player. So if X is next, so we're just grabbing this from up here. And in here we can say if X is next, then X, else O. Okay, so now we're going to click. This will change to O, click, this will change to X, click, this will change to O. So that's perfect. That's exactly what we want. And we're at the point where we can basically finish the game. So, okay, so we've gotten all of that. So now what we need to do is figure out how to calculate the winner. So this is where things get a little bit tricky. And let's think through this before we start coding. So we go through here, and we basically need to figure out if all of the combinations of ways that you can win are fulfilled. So we're going to be checking every single one of these. So what we can do is we can write out a large list of the sets of winning combinations. So we'll say calculate winner. And what do we need? We need access to all of our squares. And where is that? That is in an array. So we'll pass in a variable called squares, which will be the squares array. And here we need to figure out how we're going to store this. So we can say, let's see, winning lines. And this is going to be an array. And this is going to be an array of the sets of winning combinations. So what we can do is place this in an array, and we can go back to our board and figure out what are some winning combinations. So it'd be index 0, which is this one, index 1, and index 2. And another one could be index 0, index 3, index 6. And again, these are 0 index. This is the same way how we're going to map our array. So that's why I'm saying 0, 1, and 2, and 0, 3, and 6, even though on the board I've written them as squares 1 through 9. So then in here, we're going to have 0, 1, 2, and I'm going to skip ahead and just copy and paste these in. Okay, so now we have our set of winning lines. So what do we need to do here? So we need to get our set of winning lines, and then we need to loop through this set, and then we need to check to see if values in our squares array fulfill the winning requirement. And if so, we just need to return the winner, which is X or O. And then else, we return nothing. Okay, so what do we need to do? We need to loop through the set. So for let I equals 0, I is less than winning lines dot length, I plus plus. Okay, so now we're inside here, and we need to check to see if the values in our squares array fulfill the winning requirement. So what we can do is we can use some destructuring, which is really nice. So we have lines I, right? So lines I is just this, and we want values 1, 2, 3, or A, B, C, and what we can do is we can just destructure that. So lines I is this array, and the way we destructure an array is we basically say A, B, C, and then set that equal to lines I. So this will say A is equal to 0, B is equal to 1, and C is equal to 2. Now we can reuse this for the rest of our function. So that's the same as basically saying that A equals 0, and it's, like const A equals 0, and then const A equals 1, but we've simplified it just in a one-liner, which is really, really nice. And that is winning lines. Okay, so now that we have these variables, we just need to check to make sure they're all the same. So what we can do is we can just check that the first value is even present in this mini array. So we can check to see if this is even present. If it's null, if it hasn't been filled, we can just exit. Else, after we know that this is filled, we can then check the equality of all three of them. So what we can say is if, and then squares. So we're going to our squares array, and we're basically passing in this first index. So this index we're passing into our original squares array, which is going to come from state, and we're just checking to see what the value is there. So is it X, is it O, or is it null? And if it's not null, we can say and. So if this is truthy, if this is not null, if it's filled with X or O, we'll skip on to the next line. And we'll go on to the next line, and we can say is squares A equal to squares B, and then we'll say is this equal to squares B. So you can't do something like this. You can't do squares B C. This is a mistake I've seen a lot of beginners make in JavaScript. You can't do this. What you have to do is you have to reevaluate this line. So we'll say and squares C. So this is our whole if statement. So this will basically evaluate to true or false. This will evaluate to true or false. And then this whole thing will evaluate to true or false. So think of it as replacement. So this replaces to something, this replaces to something, and this replaces to something. And then you go through the end of the if statement. So if all of that turns out to be true, so if A is equal to B and B is equal to C, then we just need to return X or O. And what is X or O? X or O is just the value of what this resolves to. So we can just return that. So if so, return this. And if we don't return out of our function, what we can do is just return null. So down here, we'll just return nothing. If we return nothing in the for loop, that's not good, because then what happens when you exit the for loop after you haven't fulfilled all of these, you're going to return nothing. So then outside of our for loop, we are going to return nothing. So now what we can do is grab this calculate winners function, and up where our status is, we can now say const winner equals calculate winner, and then we just need to pass in our state object, which is the board squares. So board squares. Okay, so now that we have board squares, we can say if winner. So now we just need to set our status. So we can say status equals winner, and if that's true, we'll just say winner is, and then winner. So it'll be X or O. And then what we can say here is else. So we're just setting status. So if the winner is present, which is not null, so if it's X or O, we're going to display this message. Else, we're going to display this message. So now let's test this out. So we have this, boom, winner is O. So that's good. And now we can keep clicking, and that's not what we want. So what we need to do is grab this same logic, and we need to just pass it into this if statement. So we need to say if the winner is not null, so if there is a winner, or the square is filled, we don't want people to be able to click squares. So let's try this out. Winner is X. We can't click anywhere else. So perfect. We've pretty much wrapped this up. So the ultimate takeaway from this is if you're in an interview setting, you want to build the mental model first, then you want to go through and pseudocode, then you want to actually code, and you want to be talking aloud as you're going through this. That will show your interviewer that you're thinking logically, you're going through with them, you're being an active communicator with them, and then you can go through with your problems. So the whole goal is to build as much of the problem as you can without all of the complications. So pseudocode really helps reduce the complication because you've thought about it beforehand. And then for something like the calculate winner function, which is somewhat complicated at first sight, you don't actually have to build that to complete the game. You can still, add in all the functionality and everything and go all the way to the end. It just won't display who the actual winner is and won't let them stop clicking. So this is kind of like the final step, like the cherry on top. But ultimately, this is how I would approach a problem. If you like this video, make sure to like, subscribe, and shoot a comment down below with your most challenging React interview question that you've had. Also, make sure to check out my last video on a React phone screen question and my previous videos on how to get into the tech industry as efficiently as possible.